Question one is a multiple choice. This is relatively easy, right? Ask you which two substances can dissolve in each other. Like dissolve like. The rule is like dissolves in like. This means two molecules are similar in structure, then they can dissolve with each other. So give you two choices. A is ethanol alcohol C2H5OH and C6H6. Are these two substances similar with each other? Of course not. It's completely different. These have OH, this no, right? And B, C2H5OH and water. Water's structure is 2OH. Right? So this 2OH is similar as this. So these two substances can dissolve each other. So your correct choice is B. So ethanol alcohol, just think about the ethanol alcohol as any one active component is ethanol alcohol. Can they dissolve in water? Of course. So start from question two, you must show work. These are all calculations. Each step worth some point. Okay. If you only give final answer without work show, no credit. So question two asks you calculate molarity of a 2.8 m. This is molarity. Capitalized M is a molarity. 2.8 m NaCl solution, and tell you density is 1.08 gram per milliliter. Ask you calculate molarity. Okay. So first of all, we need to understand the difference between molarity and molality. Okay. Molarity, we use capitalized M as moles of solute divided by liter of solution. While molality, we use lowercase m as moles solute. So numerator is same, but the denominator is kilogram of solvent. Okay. Since here tell us this solution is a molarity, and in both cases numerator is moles of solute, right? So easiest things is so we have 1 liter solution. Because tell us molarity. Molarity is moles divided by liter, right? If we know liter, 1 liter, and molarity is known value, then immediately we get moles, right? And this moles can be applied to here. So this is the easiest. Assume 1 liter solution. So moles of solute, you immediately get it. 2.8 molar times 1 liter is 2.8 mole. So always pick the easier one because tell us molarity, and if we assume the 1 liter, then we can easily get the 2.8 more of solute. This is what we want, molarity. So we find one. Then the rest we need to find kilogram of solvent. This is a little difficult. So in 1 liter solution, we find moles of solute. Can you convert it to mass? Yes, mole multiplied by molar mass, right? Then we find the moles of solute. if we can find more of solute convert to mass, and if we can find the mass of solution, then mass solution minus mass of solute is the mass of solvent, right? Solution is more a solute plus solvent. We find the mass of solution. We find the mass of solute. Stop trying to there. Mass of solvent, right? Okay, so we convert this moles to mass first. Okay, so mass of solute will be, again, this is not a molality. Let me write it this way. Mass of solute. Mass of NaCl, the solute, not a solution. So is 2.8 more times molar mass. Use periodic table. Sodium 22.99. Chloride 35.45. Together 58.44 gram per mole. So we get the mass of sodium chloride is 163.6 gram. Then we can find the mass of solution. Because volume was in 1 liter and the density is a gram per milliliter. So volume times density is mass, right? So but this liter you need to convert to milliliter because here's milliliter, right? So 1 liter, which is 1,000 milliliter. Right? You need to use liter times 1.08 gram per milliliter. Or if you use 1 liter, then you use this unit or kilogram per liter. It's the same. You get mass as a kilogram. Right? So this is 1080 gram. Right? Then mass solution minus mass of solute is solvent. Right? So mass of solvent water is 1080 minus 163.6 will be 916.4 gram. Because molality is a kilogram, so we need to convert this gram into kilogram. The most 3 decimal place, 0.9164 kilogram. Okay, now we have moles, we have kilogram of solvent, then molality. Right. So molality M equals to moles divided by kilogram of water. Let's get 3.06. Total 4 points. Each step 1 point. 1 point, 1 point, 1 point, 1 point. Because these are all necessary steps. So each step worth 1 point. Okay. Are you okay? I can tell you, we will have similar in the test because this is all necessary calculation assured in this chapter. Molality, their relationship. Quiz, most important thing is you learn from quiz, then wish you can do better job in the test. Are you okay with this question? Okay, then 3. Here you density of aqueous solution 20% NaCl solution. density is 1.06 gram per milliliter. As you calculate molarity. The solution in percent is mass percent. And the density as you calculate molarity. Okay. So molarity, as we just showed here, molarity is moles divided by volume, right? So first of all, you need understand what it means molarity. We just talk about this in question 2. So molarity is moles of solute divided by liter of solution. Okay. Since molarity need moles of solute over liter solution, liter is a volume, right? So we can do this way, okay? So we need to figure out this mole solute and liter of solution. So we can do this way, and always pick the either way, right? So if we have 1 liter solution, this is 1 liter, right? You already know. Then we only need to find out the moles, right? Where the sour one, if we have 1 liter solution, then we need to figure out the moles, right? Moles of solute. So from this 1 liter solution, we need to figure out the moles of solute, then we need to use this condition. There you. So for 1 liter volume together with density, you can find the mass of this solute, right? Mass of solution, because this is density is mass of solution divided by volume, right? So volume times density will be mass of solution. Okay, for mass of solution multiplied by 20% will be mass of solute. Then for mass solute divided by molar mass is more, right? So from this volume, the 1 liter converted to milliliter. So liter or the volume times density will be mass. This is mass of solution. Volume times density give you mass. This is solution's mass. Solution's mass can convert it to mass of solute, because here tell you this is 20% of solution. So mass of solute is mass of solution times 20%. And for mass of solute, we convert more. Mass divided by molar mass, get more, right? The more of solute will be 212 gram divided by molar mass is the same as this question 2. And you see here will be 58.44, right? Sodium is 22.99. Chloride is 35.45. Together is 58.44 gram per mole. 3.628 more. Now we have more. We have liter solution. Then we can calculate molarity, right? So molarity, we use a bracket symbol. Moles or the 3.628. 3.628 liter is a 1. That's a 1.00. Anyway, so keep 3 significant. If you keep 2, it's fine. Okay. 0.6 also fine. Are you okay for this, man? I would say this is the easiest. Of course, we have another way. Okay. If you think this is not the easiest, we have another way. Okay. Another way is instead of assume we have 1 liter solution, because this is from 1 liter together with density, you can get a mass of solution, right? Then we could assume mass of solution. Let's say we have 100 grams of solution. 100 gram solution, 20%, then we can get a mass of solute, right? 20% times 100 gram will be 20 gram. Then 20 gram we can convert to moles, right? Because we need moles, right? The mole of NaCl will be 20 gram divided by 58.44 gram per mole. This gives us the 0.342 mole. Okay. So we will figure out one. Okay. Then we need to figure out mass of water in this solution. Okay. So total mass of solution is 100 gram, and solute is 20 gram. Then clearly the solvent is 100 minus 20 is 80 gram, right? Oh, sorry. We actually need a liter, not a kilogram solvent, because this is molarity. We need to figure out the volume, not a kilogram water. If a kilogram water, this is easy. So 100 gram minus 20 becomes 80 gram, 0.08 kilogram. That is molarity. The molarity we need volume. We need a volume. We have one condition, have not used it. Density. We have density, we have mass. Density is mass divided by volume, right? Density is mass divided by volume. Now we have density, we have mass, so we can figure out volume. So volume, this is volume of solution because the density is solution, right? Because density is mass divided by volume. Then volume equal to mass divided by density. Right, we switch to these two. Density equal to mass divided by volume. Then volume equal to mass divided by density. Okay. Mass, of course, use solution because this is density is solution. Okay. So mass is 100 gram, 100.0, let's see. Density is 1.06 gram per milliliter. So from here we get 94.3 milliliter. And the molarity we need a liter. I think that's easy. We convert the liter moles 3 decimal place. 0.043, 0.0943 liter. Now we have liter, we have more than molarity. So molarity should be more 0.342, liter 0.0943. You'll get the same polarity. Okay, so either you assume 1 liter solution is based on the volume, easily get more, or you assume 100 gram, or you can use 1,000 gram, does not matter. Okay, so based on volume or based on the mass. Okay. So which one you feel is easier, so you pick that. You're okay for this. Okay, this is each step worth some points. This is all necessary step. Then if you're okay, then next question is about boiling point, elevation, freezing point, depressing. Also calculate the boiling point and freezing point of 1.48 lowercase m, the molality. NaCl solution. In water, this is AQ in water. So Kf, Kb, two constant I provided you a table, right? So just take a look at that table. For water, Kf is 1.86, Kb is 0.52. Okay. So to calculate boiling point, a freezing point, you need to calculate a delta Tf, delta Tb first, then convert it to Tf and Tb. So delta Tf equal to I Kf and molality, right? What is I? Okay, here is NaCl, so you need to keep in mind NaCl is a strong electrolyte. In water system, in water aqueous solution, that breaks down into two ions. That's why this I is 2. Kf, this is for water is Kf. Okay. This is in water, right? So Kf is 1.86. M is 1.48. So together will be 5.51 Celsius degree. Then your Tf will be freezing point is depressing. Okay. So your Tf will be Tf0 minus delta Tf. Tf0 is a freezing point of pure water. This is 0 degrees Celsius. Minus delta Tf 5.51. So this is negative 5.51 Celsius degree. Freezing point of solution always lower than freezing point of pure solvent. Okay, that's why it's minus. So while now Tb, delta Tb is I times Kb times m. I is the same, right? Two particles. Kb, this is Kb of water. This is the water and solvent. Use table find water. Kb will be 0.52. Molality, same, 1.48. Use your calculator, you can easily get it at 1.54 degrees Celsius. So now, Tb is boiling point elevation. This means the boiling point of this solution is higher than boiling point of the pure solvent. So Tb0 plus delta Tb. This you need to be careful. Boiling point is elevation is higher than pure water. And a freezing point is depressing, it's lower than pure water's freezing point. So that's why here boiling point is plus delta Tb. And boiling point of water is 100. Delta TP is 1.54. So your boiling point of the solution will be 101.54 degrees Celsius. Okay, for question 4. Question 4 actually is relatively easier. Just use these two formulas, delta TF equal to I times KF times M. Delta TP equal to I times KB times N. The only thing you need to be careful is TF is TF0 minus delta TF, while TB is TB0 plus delta TB. These two are different. You okay with this question 4? Right. Then we have one more left. Question 5. Here you vapor pressure of water, the pure water, 45 millimeter mercury at 37 degrees Celsius. Also, you calculate the vapor pressure of a solution contains 25 gram sucrose, C12H22O11. 25 gram of sucrose dissolved in 500 gram water. After you calculate vapor pressure of the solution. And I tell you, sucrose is a non-volatile solid and a non-electrolyte. Non-electrolyte means dissolved in water, still molecular form. Do you understand this question? First of all, you need to understand this question. So, tell you vapor pressure of pure water. P water 0 means pure water is vapor pressure. 45 at this temperature. Then also you calculate the solution's vapor pressure, same temperature. This solution is 25 gram sucrose dissolved in 500 gram of water. So some solid dissolved in water will cause your vapor pressure lower, right? The formula is P equals to P0, which is pure solvent vapor pressure, times mole fraction. Now, what is mole fraction of this? Mole fraction of the solvent, because this P0 is solvent vapor pressure. So this mole fraction, of course, is solvent mole fraction, not solute mole fraction. And I tell you, this solute is non-volatile. A solute cannot vaporize as a gas. Only solvent water can vaporize as gas. So this mole fraction is solvent mole fraction. Since this P0 is already known value, right? So you only need to figure out the mole fraction of water. That's your job. To figure out the mole fraction water, so you need to calculate the water's mole and the solute mole, then find mole fraction, right? So you need to find more of sucrose equals to mass, the 5 we're on, divided by molar mass. That's the reason I gave you 0 credit. You need to use periodic table to find the molar mass of this. Use periodic table. 12 carbon, each carbon is 12. 22 hydrogen, each hydrogen is 1. 11 oxygen, each oxygen is 16. And I forgot to give you periodic table. Okay, so every time that periodic table always open to you. So you can still use that. Anyway, add together is 342. 25 divided by 342 or 0.0731. Then more of water, 500 grams. Molar mass of water, 2H, 1 oxygen. So each hydrogen is 1, oxygen is 16. Then together will be 18, right? So this will be 27.75 more. We have more water, more of sucrose. Can we calculate more fraction water? Yes. More fraction of water equal to more water divided by total mole from water and sucrose. Water 27.75 divided by total mole is 27.75 plus 0.071. More fraction is 0.997. No unit. This is more divided by more, right? This is a pure number. No unit. Now, use this formula. Let's write it here. Can you read it? Okay. So P equal to P0 times more fraction of water. P0 is 45. And more fraction is 0.997. So we get 44.9 unit is millimeter mercury. Okay. Be honest, this is not there. This you need to remember this formula. Okay. So when some solid dissolved in water, vapor pressure will be lower because solvent more fraction always less than. Again, this vapor pressure always solvent vapor pressure. Solute, this solid cannot vaporize as a gas. Only solvent can vaporize as a gas. Because this solute is solid. And tell you, this solute is a non-volatile solid. Non-volatile means cannot evaporate this gas. Are you okay with this?